All right, so same as Thursday, I don't have anything new for you. I have a second review sheet that I've thrown out there. Looks like this. There's a reason I'm giving you a second review sheet. It's because I found that it's helpful to improve scores. I hope that when you did the first review sheet, you were really asking good questions, which means if you have them, I'm happy to jump back and answer them. Remember, when you're doing a proof or when you're simplifying an identity, your process may not match mine. That is completely okay. What I'm doing is based on insight I've gathered over the years. It may not be what you're doing. And remember, there are lots of circuitous routes to get there. Some of them are shorter, some of them are longer. I don't know. Doesn't matter as long as you can get there. So does anybody, if you don't have questions, you're welcome to work. Also, you might have noticed when you're taking the quiz, I handed you a packet. If you want to staple that, you are welcome to staple it. I've got a stapler over here and there. I've just thought a lot of you like putting it in your binder, and then having that staple is a little annoying. So you make the call on that. That is your final exam review packet, given to you way early. And the reason I'm doing that is Monday I will not be here. I'll actually be here for you guys on Wednesday, but I think we're going to work on this on Wednesday and on Monday because I won't be here in the afternoon. I've got to go out of town midday. So I'm going to let you guys work on it as well rather than get you a day ahead. So you'll have some time to work on Wednesday on this, and then you'll also, I won't be here at all on Monday. Just taking a personal day. Well earned, I think. But I looked through the end of the year, and we've got time. We've got a time for me to do that, so I'm not, plus I haven't done it all year. But anyway, so hold on to that. Make sure you bring it here. I don't have a lot of extra copies. Maybe if one of you forgets it, I might be able to have one. But if a bunch of you forget it on Wednesday or Monday, you'll just be sitting here, whatever. Also, and let me caution you on this before we get into this. This is a year-long review. All right, people go, man, that's not fair. Well, one, life's not fair, but two, it's a pre-AP class. AP classes are going to test you on all year. But to be totally honest with you, that really almost plays in your favor. Because if I don't give you a year-long test, that gives me the freedom to go much more in depth in the stuff that we've done. But by giving you a year-long one, I got to water it down a little bit to do all the topics. So really, I'm not going to suggest that every problem in here is a walk in the park, because it's not. You're going to have to go back and relearn some stuff. But it is April 19th. Your exam is May 25th. You've got a strong, almost 35 days to knock this out. My advice is spend a little time on it on Wednesday and Monday. And then just let it go until maybe if you want to play around and work some problems, heck, if you want to knock it all the way out, fine, and you could redo it again if you feel like you really need to work on it when it's closer to time. But here's my advice to you. As you're going through here, any problem you don't know how to do immediately, circle and leave a breadcrumb for yourself. A trail of crumbs for yourself, essentially. So when you go back and it's closer to time, you're like, all right, I did this thing. I did some of it a month and a half ago. What was I having trouble with? So you can go back and see those circled ones and go, okay, I need to re-look over these. And I'm going to post the keys on Schoology. I'm going to post a PDF of this on Schoology if you want to reprint certain problems or certain sections. Heck, we haven't even finished everything. We still have graphing and probability to do, and none of the probability is a big section. So anyway, that's for you. So you have it. And what are we missing today? Who's that? Oh, yeah, James. Millie Kate. Yeah, we'll have to try to get them. I'll try to get it. Maybe they'll. I know she's not going to be here all week. Anybody going to go by Millie Kate's house?
I live right next to her.
Oh, yeah? Perfect.
Or you could just give it to Marciana.
Even better, since they live together. Anybody live near James? Nobody? Okay, well, he'll probably be here tomorrow. Get through that. All right, so questions on anything trig related for your test tomorrow. It's going to look a lot like this review here. You're going to have to know basic identities. You're going to have to know basic identities with actual values in there. And what I mean by that is, like, here's a basic identity. Half angle identity, you were just quizzed on that, right? But I also might have something where you use a half angle identity, like maybe this. I mean, you might look at number 18 and go, I wouldn't use half angle. I would use alpha plus beta identity to simplify that. And you can. Remember how ugly the alpha plus betas were for tangent? Remember that? I actually made a point to say, hey, remember how ugly this was? But a half angle is really simple. So I could rewrite that as what? Tangent of 150 over 2 and do a half angle a whole lot more simply than I can a tangent of 45 plus 30 doing a sum and difference identity. So you're going to have that kind of stuff. You're also going to have some stuff where basically have the right side of the identity that shows up. And you got to look at stuff like this and go, what does that look like? Oh, yeah, that looks like a tangent double angle. So I'm doing the tangent of twice 40, tangent 80. You got to be able to look at this and go, 2 sine theta cosine theta. What does that look like? Sine of 2 theta? So sine of 2 times pi over 8? What's sine of twice pi over 8? Sine of pi over 4, which is? Sine of pi over 4? Root 2 over 2? Done. I mean, that's the kind of thing you need to be able to, those kind of things. You're also going to have stuff where I ask you about a tangent or maybe a cosine of theta over 2 theta, but I only give you theta. So you use your identity to rewrite it in terms of theta and then use the triangle to fill in. We did stuff like this before. You're also going to have, I'll come back to that, a situation where I tell you stuff about alpha. Like, what am I telling you here about alpha? That by saying that the sine of alpha is this, what am I giving you?
2 sides of the triangle.
2 sides of the triangle, the opposite and the hypotenuse. And then what am I giving you here? What quadrant it's in, so you can draw it, which is important. A lot of people don't even look at this. And they always just draw a triangle, like a regular old triangle that looks like it's in the first quadrant. But if I don't draw it in the right quadrant, then certain sides don't end up being negative, do they? If I always just draw it like it's in the first quadrant, everything's positive. But that's not the case. It is here, because 0 to 90 is in that first quadrant, everything's positive. But here, 90 to 180, over here, the x is negative. So I got to make sure that I know that so I can tell where to put that negative, et cetera, et cetera. And then I can break these up using my alpha plus betas and use that information to solve. If that's blowing your mind a little bit, maybe go back and look at something and we'll talk about that. And then there's going to be probably 4 verifies in there, maybe 5, where you have to verify the identity. And if I don't give you enough room here, don't worry about that on the test. I think I put 4 on 1 page. So you've got tons of room to work and to show me your steps, whether you take my steps or not. Again, probably half of you, at least half of you will do a different method than me. Sometimes a different method completely, and it will be right, and that's totally fine. So my key, don't think my key is the right way. It is one way to verify. And then you also might have simplifying. And what's the main difference between simplifying and verifying? Simplify, what's your goal? Make it more simple looking. Verify, what's your goal? Make them equal. They might look uglier than normally they don't. Most people start to simplify it, cleans it up a little bit until they match. But here you're making a match. Here you're cleaning it up using an identity you know. All right. So anybody got a question on anything? This thing or last one? Yeah.
Right now, number 26 on YouTube. It's a part of verifying one.
Okay. So have you done anything on it? Does anything jump out at you?
I don't like the using 5 or just like that's like sort of confusing.
It's confusing, or
Like I just don't know what to do first.
okay. So here's some options. If you ever get completely stuck and you have no idea what to do, it's not a terrible idea to change it to sines and cosines. But I don't usually do that initially because there might sometimes in doing that, it just creates more mess. Gives me more steps. I mean, it just gave me one more step, just writing it out. So I'm looking for something a little bit better than that at first. Second thing is, remember, I'm trying to make these match, right? So if I'm trying to make a match, what I normally do is I start working on the ugly side because I'm a little more used to taking ugly and making it simple, right? So when I look at this, I'm like, okay, this side is clearly uglier than that one, right? It's a little bit bigger, longer. I got to turn this into that. Now, the only hint that the left side could possibly become the right side, to me, is the left side has secants in them. And secants are essentially cosines flipped, right? So that kind of makes sense. And then I got sines, and I look at these sines and I go, well, tangents are sines over cosines. So that might account for the sines. So that might be something I can work with. But honestly, at this point, it might be a good idea to just go sines and cosines and just see what I have. So what if I were to do that? Change everything to sines and cosines. The left would be what? A sine to the 5th power. And what does secant cubed become? 1 over cosine cubed. So where would I put the 1 over cosine cubed? Down below, because they're multiplied together. That's one term. And then over here, I have a sine cubed of x. And that secant squared also becomes a 1 over cosine cubed, which puts it down below. So I'm done cleaning that part up right here, or changing it to sines and cosines. And over here, that negative tan cubed x, I'm going to leave the negative. I'm going to change tan cubed to sine cubed over cosine cubed. And then I have a times cosine squared. Now, right here, if you're tempted to go, oh, I could cancel those cosines. You could, but I'm not going to right now because these are cosine cubes on the bottom. This is a cosine cubed on the bottom. Kind of looks good to me. So at this point, I look at this and I go, well, is there anything I could do here? You might go, oh, well, I have a common denominator. If I have a common denominator, can I add the numerators? Sine 5th x minus sine cubed x. That's like going x to the 5th minus x cubed. All right, now I got to start being creative. I'm trying to make the left and the right side match. I've already got the cosine cubed there. That part already matches. What can I do to the top here that might help myself? So factor out a sine cubed. If I factor it out, and that is one of the rules for simplifying, try factoring. I mean, PEMDAS doesn't have F in it, but sometimes when we factor here, I could cancel. And sometimes when we factor, it leaves me something that might change into something else. That's what happens here. Look, if I factor out a sine cubed x, I'm left with what? Sine squared x minus 1. Oh, wait a minute. What is sine squared x minus 1? Be careful. What is it? It's a negative cosine squared. So I'm going to replace that. Plus, if you look to the right side, the negative had to come from somewhere, right? That's a sine cubed, a negative cosine squared over a cosine cubed. Well, look, that checks off right there. I mean, I know it's technically not exactly the same, so if you want to go, oh, I can pull that negative out since all I'm doing is multiplying. Now they match. That is one way to go, but just one way.
Could you also pull out a common factor at the beginning, like sine?
And there's zillions of ways to do this, right? If I pulled out a sine cubed, that would leave me, and a secant cubed, that leaves me a sine squared x. I pulled everything out minus 1, right? Think about it. I pull out 3 sines. That's 3 of the 5, leaving me 2, and 3 secants, 3 sines, 3 secants. So there's 2 sines left and a minus 1. And then now, look, I could forget this right side. Look how much simpler this is going to be. Simpler it's going to be. Sine cubed. That secant cubed becomes a what on the bottom? Cosine cubed. What does sine squared minus 1 become? Negative cosine squared. And what is that? Tangent over, sine over cosine is tangent. So that's tangent cubed. So there's my tan cubed. There's my cosine squared. There's my negative. So much simpler. Took me 3 steps instead of 5. In fact, I really only would have taken me 2 if I went, wait, I could just change this to negative sine cubed over cosine cubed and just drop down the cosine squared. They match right now. And it would have only taken me 2 lines of work. But never do I want to go, hey, I'm just going to multiply both sides by a sine, or I'm going to divide both sides by a sine. Or don't ever do that, because remember, this is not saying they're equal. This is saying, are they equal? So I'm trying to make them match. And if I can make them match, great. I can't. And remember, if you can't, don't just say not an identity. You can't just throw around things like, oh, that's not an identity. It just doesn't feel like it's one. What do you have to do if you think it's not one? Plug in a value for x and see if they're not true. And what would be, and you always go back to the original in case you made an error, right? Because you don't want to check your error. You want to check the original. What would be a good angle? Like, what angle do you feel comfortable plugging in for a sine, a secant, and a tangent? 90. I got to be honest with you. Be careful plugging in 90s and zeros and 270s, because 90s give you undefines a lot of time. Like, what's the cosine at 90? And if tangent is sine over cosine, you got an undefined right here. So I tell you what I normally do. I like 45 degrees. 45 degrees actually usually gives me something really nice with tangent, because what's the tangent at 45? 1. And what's sine at 45? Root 2 over 2. And what's cosine at 45? Root 2 over 2. So if I need to do secant, I could just flip the root 2 over 2 and make it 2 over root 2. Right? So I like stuff like 45 or 30 or whatever, really 45 when I'm done with tangents. It just makes it really easy to plug in and check. But this was an identity, so you didn't have to worry about that. What else?
Wait, so are they sometimes like not an identity and you write not an identity?
Yeah, so like let's just say you were doing the math and you accidentally wrote sine squared minus cosine, sine squared minus 1 is cosine squared, and you got down to here and you're like, wait, that's negative and this is positive, and you're like, man, I don't think that's an identity. Well, then you go check. So if you think it's not one, this one is, you just made a careless error. But
Yeah.
Hypothetically, if you thought it wasn't, you could come back up here and go, all right, what's the sine of 45 to the 5th? Secant of 45 cubed, this would be a little ugly, sine of 45 cubed, secant of 45 cubed, and then you'd have negative tangent of 45 cubed and cosine of 45 squared. So you could go in here. Now, it's not going to be super wonderful, but check it out. This would be root 2 over 2 to the 5th. That's going to be, if cosine of 45 is root 2 over 2, what's secant of 45? Just flip it, right? And then you would just go through there, root 2 over 2 cubed, 2 over root 2 cubed, and then tangent of 45 is just 1 cubed, and cosine of 45 is root 2 over 2 squared. So you would have to simplify these. This is really nice. What does this become? Just look at it. And leaves me what? 1. So all of that's a 1. And this is not super fun. What's the root 2 over 2 to the 5th? I would look at this and go, well, 3 of those are going to cancel with 3 of those, leaving you how many? 2. And what's 2? What's square root of 2 squared? And then I'm going to have 2 3s on the top, 5 2s on the bottom, leaves me 2 2s on the bottom. So I get a half minus 1. So if I was doing all the checking on this, I would have got negative a half over here. And over here I get 2 over 4, which is negative a half over here. And I would go, wait, it is equal. No, I must have made a careless error. But I got to be honest with you, careless errors are usually very abundant on this test, but rarely do I give you not an identity. It might happen. I had a kid once, I gave him it was like an entire test was an identity test. In regular pre-cal, we used to do identities too, but we'd spend more time on it because it was regular pre-cal. So we'd spend like a week on it and have a test just over trig identities. I mean, just literally over proving identities. And maybe it was a big quiz or whatever. And I had a kid, I think we had to do like 12 of them or something like that, or 10 of them. He walked up, and said, dude, I caught him. I'm like, what are you talking about? He goes, man, I found all 7 of them. All 7 of what? He goes, of the ones that weren't identities. And I was like, well, that's unfortunate because there was just one. He just made so many errors. He just assumed they weren't identities and wrote not an identity, not an identity. But I think there's like one. So normally there aren't any, but there might be one. And I think on your review, maybe there's one. I haven't looked at the key. But I sometimes I do that just to keep you honest.
You do 22.
All right. So there's 2 problems here. 22 is asking you to do the tangent of twice that angle. So I have to use the angle theta to answer questions about twice theta. Well, I can't do that. I mean, like right now, if that's theta, then twice theta probably looks like this, right? Way up there. I have no idea. If I go all the way up there, whatever, I have no idea what this side is. I mean, I do know that this is still 12. That's not 10. When you double the angle, you don't double the side. If they did, that would be great, but it doesn't work that way. So what do? Well, I got to get rid of that, right? I can't use this information, so I have to use just the theta. Well, I've got all kinds of angles. I'm sorry. I have one formula that works with double angle. And what is it? 2 tan theta squared theta. So what is the tangent of theta? Replace tangent theta with 5/12, drop down to 2. Replace tangent theta with 5/12, bring down the squared part. So all you have to do is clean this up. So what can I multiply the top and the bottom by? I'll show you this error. What can I multiply the top and the bottom by that would make all these denominators go away? A lot of people say 12, but do I really have 12 there, or do I have 12 squared there? You see that? So a lot of people multiply by 12 here, 12 there, 12 there, but that's not going to get rid of 12 squared. So I got to multiply by what? 12 squared there, 12 squared here. So I'm going to distribute the 144 in, cancel anything that cancels on the top. 10 times 12 is left. 144 times 1. And what's 144 times this fraction? Yeah, just the 5 squared would be left, so minus 25. So all I end up with is 120 over a what? 119? Not too bad. And then cosine of theta over 2. Now I want half this angle. Well, if I half the angle, I don't know what that little part is. It's not half of 5, just not. All right. So if it's not, what do? I don't have that triangle for the half of the angle. But can I rewrite that in terms of theta so I can use this? Of course. So what is your identity for a half angle cosine? Is it plus or minus, or is it plus or minus and you decide? You decide. So if I'm going to half this theta, what quadrant would that angle theta over 2 be in? Yeah, because it's already acute. If you half it, it's even more acute, isn't it? So I'm taking the cosine of a tiny angle in the first quadrant. What are those cosine values when they're in the first quadrant? All students take classes. Cosine's positive in the first and fourth, right? So I know this is positive. I use the plus. And then 1 plus cosine of the regular angle over 2 And now I don't need the half angle, I can use the regular angle. So what is the cosine of that? 12 over this. That's, you recognize that triple? 5, 12, 13? So 12 13ths. What did I do wrong right here? I see this every year. What did I just say by writing this?
That theta is 12.
Yeah, but you're both right. But what I was looking for was, I just said that the angle was 12 13ths. The angle's not 12 13ths. What's 12 13ths? The cosine of this angle. So don't replace the angle with 12 13ths. Replace the whole thing with 12 13ths. And now what's the common, does that make sense? And what's the common denominator of that, and that? 13, because this is 1 over 1, this is 2 over 1, that's 12 13ths. So when I multiply the top and the bottom by 13, this is the way I like to do it. I end up getting 13 plus 12 over 26. Are you with me? And what would I do here to clean that up? I mean, granted, it's 25, so it's 5 on the top over a root 26, but what would you have to do to clean that up? Rationalize. So multiply the top and the bottom by root 26, and you get 5 root 26 root 26 over a regular 26. What else you got? Are you feeling good about it? Anybody on that first one have any questions? Run into any trouble they want to talk about?
Can you do 23 on the first one?
On the first one? So we might have done that. Did we do that in a class or not? Maybe it was fifth year. So when I look at this, the question is to prove, right? So again, I'm not simplifying. I'm trying to make the left equal to the right or the right equal to the left. So again, a million ways to do this. But is there anything that jumps out at you initially? This is not a super easy one. So if you see something like this again, it would probably be similar.
I just didn't know how to sign the 4x.
Yeah, I don't either. So what do you know in terms of sign?
Sign of 2x.
Sine of 2x? Could I rewrite this as sine of 2 times something? Just because that's my only option.
Oh, sine of 2 times 2x.
Okay, so what if I said sine of 2x? That's technically sine of 4x, isn't it? Now you might look at that and go, Mr. Hurry, you could write that as sine of 8x over 2 also. How's that helping you? Well, you're right. I can write it as sine of 8x over 2. But guess what? I don't have a 8x over 2 formula. I do have a half angle formula, but 8x is not helping me, right? It's not getting me anywhere I need to be. 2x is getting me somewhere I need to be. So I want you to think for a second. What would you do if I had, I'll do it right here. What if I had sine of 2 theta? What identity would you use for sine of 2 theta? 2 sine theta cosine theta, right? So what could you use for sine of 2x?
It'd be 2
sine of 2x cosine of 2x. That's what I can do right here. So I can change that to 2 sine of theta, but my theta is 2x, cosine of theta, but my theta is 2x. Now it still doesn't match, but look, I'm getting closer. There's my cosine of 2x. It already matches. Well, let's try something else. If the cosine of 2x already matches, I'm not messing with that anymore. What about sine of 2x again? How could I break this sine of 2x down?
You could do it again.
I could write it as 2 sine of now regular x, cosine of regular x. Drop down the cosine of 2x, and doesn't that now do it? That's just one way. How about a better way or another way? What if I didn't see anything on the left? Like you said, man, I don't know what to do with that 4x. Okay, fair enough. You have no idea. But you look over here on the right and you go, well, I don't have a rule that says 4 sine x cosine x, but I do have a rule that says 2 sine x cosine x. If I break that 4 up into 2 times 2, so what could I replace that 2, remember I broke the 4 up, with that sine and cosine? What is that? Anybody? What is that?
Oh, it's sine to angle.
That's sine of 2 angle, but the angle's x, right? So this becomes sine of twice the angle, and the angle is x. All right, so I bring down that and I bring down that. Now what do I see? What's 2 sine blah cosine blah? What is 2 sine blah cosine blah? 2 sine blah cosine blah is sine of 2 blah. 2 sine blah cosine blah, sine of 2 blah. 2 sine blah cosine blah is sine of 2 blah. Are you seeing it? There's your 4x. That's just 2 different ways to do it. Lots of others. There actually are quadruple identities. They're out there. They might not be beautiful, and we don't memorize them. But like those triple angles that some of you actually memorized, I can prove those using an alpha minus beta identity. But instead of doing alpha and beta, I do theta and 2 theta, which is 3 theta. And then I just do all kinds of little substitutions and manipulations, and poof, out comes an identity that looks kind of cleverly, easy to memorize. You know, and I rewrite the sine in terms of sine and the cosine in terms of cosine, whatever. But those come from alpha plus betas, and I'm just manipulating them. But you don't need to know them this year. Maybe next. What else, guys? 17. All right. So what's bothering you about it? The radian? Okay, so if the radian bothers you, you got a couple of options. One option is get rid of the radian. Change it into a degree. Don't make the mistake. I have people every year that change it into a degree and write the degree as their answer. Now, if you change it into a degree, then you still have to take the cosine of that degree value. So if you want to, you could say, all right, how do I change this radian into a degree? What do we multiply by? 180 over pi. And why does that work? Because 180 degrees and pi are in the same place. So it's like multiplying by 12 inches over a foot, like stoichiometry. But it does cancel and leave me degrees. So I end up with 12 under that 180, which is not approximately 15 degrees, right? So don't say 15 degrees my answer. I'm just changing that to 15 degrees. So now, what could you do? 45 minus 30 is 15. I could have also used a half angle, couldn't I? 30 over 2. That would have worked. But I like alpha plus beta, alpha minus beta is better than half angles with sines and cosines. If I have a choice, I just like them. They're better looking answers. So what's my rule? Cosine of the first, cosine of the second, and then change it to a plus, sine of the first, sine of the second. So root 2 over 2, root 3 over 2, plus root 2 over 2, 1/2, root 6 over 4, plus root 2 over 4 is root 6 plus root 2 over 4. And if you do half angle, it'll look totally different. But look, you don't even have to do this. Half of what Let me ask you a better question. Is there an angle on your unit circle that if I half it, gives you pi over 12? Pi over 6. So I could say that is the cosine of pi over 6 halved. That's a half angle. And I could have done it like this. What's the half angle identity? If that's your theta, what's the half angle identity? The square root of 1 plus cosine pi over 6 over 2. I could just simplify that. Your answer is not going to look like this, but it's going to equal this. It's just a less simplified answer. So, and it's positive because pi over 12 is clearly in the first quadrant. Everything's positive in the first. So cosine of pi over 6, root 3 over 2. What do you multiply the top and the bottom by? Regular 2 over a root. I got to multiply the top and the bottom by 2. So I distribute that in, multiply that in, and the square root of 4 is regular 2. That doesn't look like this, but if you type them in your calculator, they're actually the same. Here you're doing a square root of something plus a square root. There is a process to change that into that, but we don't get into it in this chapter. More of a math team kind of thing. You've actually done some work on it. You would do this. The square root of that is equal to some x plus some y root 3, and you would have to square both sides. I don't know if this is starting to look familiar to you. And then you'd have to put all the root 3 equal to that, and put that equal to that plus that, and you'd have to guess and check and find your system. And when you do, you'll end up with an ugly looking answer that would be something like this. But we don't get into that in this class, so we just leave it like that. But you have two options on a problem like that here. Although I'd probably do the first one. See it?
Could you do 32? If you have time?
Okay, I'll tell you what my thought process is real quickly. My thought process is this cosecant and that cosecant and this cosecant and cosine. It might kind of be just easier to think about it in sines and cosines. Might not, but it might be. So if I changed it to sines and cosines, make sure you don't do this. Guys, if this cosecant's being subtracted from that, you can't just move it down when you're being subtracted. You can't do it. If it's being subtracted, you just flip it right where it is. Now, if it's being multiplied, you can swing it up. It's multiplied, but not if it's being subtracted. So here, I'm just going to flip that one where it is. And then here, I'm actually going to flip this one right where it is too. Why? Because it just cancels nicely. See that? And then over here, I'm going to change that and just put a sign on the bottom. So at this point, I have sine x minus 1 over sine x equals negative cosine squared x over sine x. Now my hint to what I should do is, if that has a sign on the bottom, this already does, doesn't it? Well, that's a good thing. So let me just find a common denominator. So I'm going to put a sign there and a sign there, and that gives me sine squared x minus 1. And then what can I do now?
The top is the identity.
That is what?
It's cosine.
Careful.
Negative cosine.
Negative cosine squared. So now they match. But that's just one way of going about it.
I think you grab
All right? All right.
Mr. Hurd, you have your copy of the second review? I think I lost one.
I doubt it. Here, let me turn this up. I doubt it, but I can look.
Is it on Schoology?
You'd have to print that part of the book.
Okay, that's fine.
But let me see. Hold on.
Yeah, I don't have it.